A force more powerful than gravity within our Earth. How magnetism locked itself inside our planet. As the magma cooled to form what is today the world's solid outer crust, magnetism was locked into minerals containing iron, such as magnetite. The image of an atom with electrons swarming around a central nucleus bulging with protons and neutrons is as iconic in our perception of science as the DNA index or the rings of Saturn, but however much we scratch the surface of these scientific fundamentals, we can go even deeper, focusing that microscope further and discovering even more forces that govern our world. In his new book, Charge, Why Does Gravity Rule?, theoretical physicist Frank Close explores the fundamental forces that govern our world, posing questions along the way that seek to explain how the delicate balance of positive and negative charges paved the way for gravity to shape our universe. In this excerpt, he explains how magnetism, the most tangible fundamental force, was discovered, where it comes from, and how it got its name. The force within. Magnetism is a manifestation of electricity, and vice versa. Electricity and magnetism were imprinted into our surroundings from the beginning. 5 billion years ago, when the newborn Earth was a hot plasma of swirling electrical currents, these flows created magnetic fields. As the magma cooled to form what is today the world's solid outer crust, magnetism was locked into minerals containing iron, such as magnetite. And today, the Earth's liquid core is still a terpsichorean frenzy of electric currents which generate a magnetic field. This extends into the atmosphere and far beyond, invisible to our normal senses, but in spreading from its source in the molten core to the heavens above, it first permeates the Earth's crust. And this is where it leaves a tangible imprint, evidence that there exists a force more powerful than gravity at work within the Earth, whose influence extends very far. Way back in the earliest Precambrian, 4 billion years ago, as the surface cooled, atomic elements accumulated in the strata. The most stable of these, iron, is today one of the most abundant elements in the crust. Igneous rocks formed from volcanic lava. These rocks have the property that in the presence of the magnetic field, their atoms of iron act like soldiers on parade as they themselves become magnetic. This is exploited in popular demonstrations where the magnetic field of a bar magnet can be made visible. Small filings of iron are first scattered on the surface of a table and then the magnet is placed carefully among them. Its magnetic field induces magnetism in the iron filings, turning them into thousands of miniature magnets. Each of these duly orients itself in the magnetic field, revealing how the direction of the magnetic field varies from place to place. The bar magnet is a simple model illustrating what happens for the magnetic Earth itself. Earth's north and south magnetic poles are analogous to those of the bar magnet, our planet's magnetic field extending far into space. There are no iron filings out in space, but there are large amounts of iron ore in the hills, cliffs and mountains on Earth. In some places, by chance, these magnetic clusters are quite extensive, as on the Isle of Elba and Mount Ida in Asia Minor, where large outcrops retain the magnetic imprint in rocks known historically as lodestones, now named magnetite. There are legends how thousands of years ago in ancient Greece, a shepherd wearing leather shoes held in place by iron nails stumbled literally across magnetite when the powerful magnetism gripped the nails in his footwear. Whether or not the shepherd named Magnus discovered the eponymous rock, and if so, whether it was in Magnesia, north of Athens, Magnesia, or on Mount Ida in Asia Minor, or even another Mount Ida in Crete, it's very likely that such experiences, if less dramatic than in the story, would have happened on various occasions. Certainly the power of magnetism would have been apparent ever since the Iron Age. Lightning is a flash of electric current which generates intense magnetic fields and magnetizes ferrous rocks. Smelting to retrieve the pure iron metal from those sources would have revealed their magnetic attraction. So the phenomenon has probably been known for some 3,000 years. Like the discovery of fire, that of magnetism probably arose in several places independently, all inspired by the natural magnetization of iron in rocks. For magnetic rocks are ubiquitous. By the 16th century, travelers recorded the best examples from East India and the Chinese coast. Very massive and weighty, the stone will draw or lift up the just weight of itself in iron or steel. Robert Norman, the New Attractive 1581, said, as knowledge of the phenomenon spread from Greek myth to Latin and on to English, the names morphed to Magnus, rock or magnet. And this is by Frank Close, Emeritus Professor of Physics at Oxford University, and this is on Life Science. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.